Okay, welcome everyone again. In the last lecture, we have discussed about constraints. Now today's topic is indexes. What is an indexes? Indexes is a performance tuning method for faster retrieval of the records. Very simple. Now, just for your understanding purpose, what the indexes is. Now, when we talk about index is nothing but it is a record of each value that appeared in the indexed column. Very simple. Now, if you can compare it with a book, when you're opening any book to read, you might have seen the first page as an index. What you see on that index? Nothing but a page number and topic. So when you want to speak, when you want to search a specific topic, you directly jump to that page number and open that particular topic. Same thing happens here. What happened that when you create an index, Oracle create an entry for each value which is available in the indexed column. Now, one thing you have to remember that if a column or a set of column has a unique or primary key, then you cannot create an index on those columns. Reason, it is not allowing not that. Reason is Oracle has already created index on this, that is with a system generated name. Very simple. Now, in indexes, simply how many types of indexes are there? So here, there are several types of indexes available for use in Oracle database. The most common are B-tree indexes. So when we are not specifying what type of index we are creating, that time by default, it creates a B-tree index. What is a B-tree index? B-tree index is a balance tree index. This is created specially when distinct records are more. Distinct simply more means what? When you don't have a much duplications, then we create a B-tree indexes. B-tree indexes further divided into the two types of index. One, simple index, and second, function-based indexes. Second is called a bitmap indexes. Bitmap indexes we have to create especially when your column has a multiple or lot of duplicate values. Very simple here. Simply, while creating an index, we use a keyword bitmap. Create bitmap index, index name on table name. And then you have to specify the column for which you are creating an index. And next is called as a reverse key index. Now, in this case, what happened? When you are creating an index column value is reversed, especially to avoid index contention. What do you mean by the index contention? Sometimes we have a column which does not have multiple values, which have a very few values. For an example, a gender. Now, gender are either M or F, that's it. So that kind of records we use a reverse key index. So how do we do that? Same thing, create bitmap index and then index name, use a column, just use a keyword reverse, that's it. Okay, so mostly we never create a bitmap or reverse key. We always go for B-tree indexes. This is a default indexes available in the Oracle. Now, what is a B-tree? Simply, B-tree means your index is created in a tree structure. That is called a B-tree index. Now, just four things you have to remember about these things. In a tree, records are stored in a location called leaves. The starting point is called the order of the tree. and the maximum number of access operation required to reach desired leaf is called a depth. So simply you have to remember the four things: leaves, root, order, and depth. Depth is also called as a level. Very simple here. Now, why we call a B tree here? B tree is sometimes called as a binary tree, but in here, it is not a binary tree. It is a balanced tree. What is a balanced tree? Every depth and every order has a same number. That is, the indexes are balanced tree. The order is the same at every node and the depth is the same for every leaf. Very simple. Now look at this. You can see the two indexes here. One is balanced tree. Second is binary tree. Correct? Now in the binary tree, this is a starting point. We can call it as a root. Simple. After the root, it has a two orders, 1 and 2. Again, this has a 2, 1, 2, 1, 2. So now here the leaf is 2, 2, 2, 2, 2 everywhere, and it can go n number of depth. So here, if you check, order is always a 2 at every place, 1, 2, 1, 2, 1, 2. But depth is 1, 2, 3, and 4. लीफ तक पहुंचने के लिए डेप्थ कितनी है उसकी 4. Balanced tree, everything is balanced. This is the root. We have a 1, 2, and 3 depth. So 3 order. Same way, depth is also 3, 1, 2, and 3. And every depth has a 3 leaf. So leaves are 9. So totally balanced. So this is the difference between the binary and balanced tree. Very simple here. Now, this is just for the understanding purpose what the balanced tree is. Now, how to create an index is a very simplest task. Syntax is create index. Unique is a optional keyword. When you use unique keyword while creating an index, index will not accept duplicate value. So usually we create a index without unique, because for unique, we have learned the constraint and we can apply that constraint on the particular column. Simple. Now, just let's see practically here. Okay, so this is the place where we are going to see it practically how to create an index. Now, we have created one table, select star from, we can say students, or I'll take a table called as Bollywood. Already we have it here. So take it from Bollywood. This is the table we have, which has a certain records. 14 records we do have. So simple here. Now if I'm retrieving the records, records are coming from first record to last record in the table. Very simple here. So now when we create an index, what will be the benefit? Benefit is that record will come by referring the indexes. So let's say we want to create an index on age. Now you will see that age is not, we are getting according to available in the table. So here, how to create it? You have to say create index name. So you can give any index name. I can say IDX as a name of index, underscore age underscore Bollywood. Simple. Then create index name on. We are creating on which table? Bollywood. So we'll use it here. Correct? Then you can choose the column. Now the column we are choosing it here as a H. Simple. Now this you can choose either a descending or ascending. By default, if you're not choosing anything, it's a ascending order. Now let's execute it here. Okay, we got a message index created. Simple. Now if I'm retrieving the record, you will not see any difference. Reason is we are retrieving all the records. आपको अगर पूरी book पढ़नी है, तो does it make any sense that you go for the index first? Or you can directly start from the first chapter and go up in the last chapter. But when we are looking at based on specific age, that time index will be accessed. So now, here if I say, select star from Bollywood, where age greater than 70. Now I'm retrieving all the record जिनकी age 17 years से ज़्यादा है. So let's execute it here. We got all the records on the list. This time it has accessed the age. Now it's very difficult to find out whether it has gone through or not. So you can see the explain plan. Okay, take a time, just hold it. Now you can see here. Unindexed column are shown in red. Now here, you will see that what was has been accessed. Simply, it has accessed the age. This index has been accessed. Very simple. It's a non-unique and it has been accessed. So you can see the explain plan. What is here? Select statement, table access, full. Option is full, Bollywood. And we got a set 14 rows, time is 1. Very simple. This is showing you the explain plan. Clear? So let's do one thing. We will drop the index. So dropping the index, syntax will be the same. Drop index, index name, idx underscore age underscore Bollywood. We have dropped the index. Let's create an index again, but this time we'll use a descending. And we create it. Index is created. Now again, we are executing the same thing here. You can see that this time we are getting a data in a specific order. Age 50, 50, 38, 32, 32, 18 is the last. Descending means what? High to low. Simple. Now, why are we getting this? I'm getting all the 14 records. Let's say I'm not using a where condition, I'm retrieving the records. But we are getting the record in an ad hoc order. But when I'm using this, I'm getting in a specific order of age. Reason is now we have chosen the column for condition, which is indexed column. Simple here. Hence it is indexed column and index is containing the record in descending order. Hence it is containing in a descending order. Then record are also shown in a descending order. Very simple. This is the how we create an index, and indexes are useful only for retrieving the data. Simple, not for inserting, updating, or deleting a data, but for retrieving the data. Let's go there. Syntax to create an index. We have seen that how it is created. Simple here. Now, next is called a function-based index. What is a function-based index? Now, what happened when we are storing the data? Data can be stored in any form, but sometimes we retrieve the data in a specific format. Now, for an example, when we are inserting a data, it could be in a lowercase or a uppercase, but always we retrieve the data in uppercase. Simple. That means while retrieving the data, we use a function upper. So if index is there on that column, it will not help until that index is also storing the data in uppercase. So what we do, we choose the function while creating a index. So simply how to create a function-based index? Same thing, just before the column, we choose a appropriate function, what is our required. So simply we can say that create index name on table name. In previous, we have seen that we directly put the column and we use either ascending or descending, but here we choose a function. So once you choose a function before the column, we have to use a keyword called as compute statistics. We should be used a keyword called as compute statistics. Simple. If we are not using this, we will not get any error. There won't be any error in that, but index will remain the blank because this keyword makes sure that function got executed and data is collected after execution of the function. Now for an example, here I have given the example as well. Create unique index name on table name. I'm using a function upper. I'm sure everybody know what the upper is. Upper is nothing but which convert a character into upper case. So we say the upper, then I'm using a column name. Ascending I have chosen here, but even if I'm not choosing, by default it will be the ascending. And hence we have used the upper, we use a keyword compute statistics. Simple. If I'm not using the compute statistics, what will happen? It will execute, no error will be thrown, but this index will remain the blank. Now, if you have a book in your hand and there first page is written index and that page is totally blank, will it help you to retrieve the data? Will it help you to find out a specific page where you want to go? No, same thing will happen here. So you have to use a keyword called as compute statistics. Very simple. Now, what if we forget to use a compute statistics because we are not going to get any error as well. So in that case, you can alter the index. So suppose you forget to collect statistics on index. Collect statistics means using that keyword compute statistics while creating an index, or you want to update the statistics. Simple. Sometimes what happened that it is collecting the statistics, but in future sometime that is not sync with the actual data. So you want to update it. So in that case, we can use a alter index statement. Simple here. Now syntax is also very simple. Alter index index name rebuilt. Alter index, index name, rebuilt, and use that keyword compute statistics. So your index will be rebuild it. Very simple here. Okay. Let's move ahead. Now, some important part for you, that is called a clustered table in Oracle. What do you mean by the clustered table? Now, when we create a table, the table gets created in a workspace is provided to us. Simple. Now we have created a table students, we have created a table Bollywood. So they are independent. Very simple. Now you can imagine in this way. Okay, let's say this entire area, what you can see on your screen, this entire area assume as a RAM or a memory, physical memory. So in that case, I am creating one table with the syntax of create table. So one table is created, that is created here. When I execute a second statement of create table, that could be created here. Because that time, whichever memory is allocated to you, according to that, it is going to create. So one is here, another is here. Simple. Now let's say this table and this table are related to each other. Related means what? Let's say this is the husband's, this is the wife's. And we want to retrieve the record, which should be the combination of husband and wife. Okay, that we are going to learn with the help of join. अब मुझे जो records retrieve करने हैं उसमें husband भी चाहिए और wife भी चाहिए. So we perform the join. So let's say here we have a ID. Correct. Now I have an ID from 1 to, let's say, 6 records. Okay, we can see here A, B, C, D, E, F. Okay, same way in wives, we have a ID. Okay, we can say here Mr. A has a 2 wives. So ID will be the 1 how many times? 2. He has a 1 wife as Z, 1 as Y. Mr. B is a bachelor. Mr. C has a 1 wife. So we'll say here 3 and M. Okay, same way we have a n number of records here. Now here what we want? We want a combination of both. So in that case, when we write a query or a join, what happens? This will look at this 1A. So it will take a 1A and it will go to this table for searching the matching record of A. So here it comes. Look at the first. It will add 1 Z. Again 1A and 1 Y. Correct? It's a search here or it has printed this and again it come back here. Go for the 2. Up 2 ke liye, it will start search from the first record again. And it will keep on searching up to the last record. Correct? So the problem will be now, problem will be that this table need to be searched for the number of time the number of records are available here. Then what is the use of clustering? Clustering is spatially you create a memory area where related tables are stored together. Where the related tables are stored together. Now for an example, let's remove this. sorry, we'll say the delete, and we'll say here no borders. Okay, so now we don't have anything here. So instead of that, what we do, let's say we declare one area. I'll remove this first from here. I'm keeping it here. Okay, let's say we declare one area this much. Now this area, we said that all related data should be stored in the same place. So now this is nothing but called as, now in which what we decide कि इसके अंदर सारे related data होना चाहिए. So what is the related? Now in these two, how you come to know that Z is related with A? Because of ID. So this cluster required one thing called as cluster key. So you are deciding the cluster key while creating a cluster. Correct? So let's say in this we have decided a cluster key as an ID. Now we can create those columns which are having the ID column. So now when I'll create this column in the cluster, so this column will be a part of this cluster here. Sorry. Correct? And this again, if I want to create in a cluster, now instead of getting created anywhere else, this will also be a part of this cluster. Now in this, what happened that whenever you have a cluster, related data stored at same memory address. Now for an example, 1 and 1 are related, so it will be on the first row. 2 and 1 is not related, so this 2 will not allowed here. This will go down. This will remain the blank, but this is related to 1A. Simple. 3. Now 3 is not related with the 2, so this 3 will be instead of here. So now searching will be the easier. On the same row, who all are sitting or who all the records are there, they are related to each other. That's called a cluster. Now for cluster, what to be done? Simply you have to follow the 3 steps. So first thing you have to understand about the cluster. This was just an explanation. Now table with common fields are stored together. The common field is called as a cluster. Now we have seen that in our example, it was ID. The record with the same cluster key are stored together for faster access. Just now you can connect with the example what we have been seeing. Now here, simply we can say that how to create a table into a cluster. So it's very common sense. अगर मुझे किसी टेबल को क्लस्टर में क्रिएट करना है तो सबसे पहले मेरे पास क्या होना चाहिए? क्लस्टर. So step number 1 is create a cluster. Syntax wise, create cluster, cluster name. Create cluster, cluster name. Then we provide a cluster key that will be according to your requirement. Here I am choosing an ID. ID, their data type and size. Then you have to define the size of the cluster. Size can be given anything according to your need. So here I have given size 512. Then you say entire 512 should not be occupied at once. So we decide the type of storage with the keyword storage. And we give the first word as initial. Initial 100K, next 50K. What's the meaning of that? Out of this 512, first 100K will be occupied or utilized. Once that is done, next 50K will be released up till the total size of cluster. That's the instruction we have given for creating a cluster. Very simple. Then step number 2. Once you create a cluster, then you have to create an index on that cluster. Very simple. So we say that create index name on. Earlier we have seen that we have created a cluster index on a table, but this time we are creating an index on cluster. So create index name on cluster. Then give the cluster name. Test cluster. Very simple. So after giving this test cluster, this index will be created. But you might be noticed here that no column name is provided. Usually while creating an index, we provide a name of the column. So here, this index is created on cluster key, automatically on a ID. That's why we never provide a column. Very simple. So step 1, create a cluster. Step 2, create an index on the cluster. And step 3, adding the table to a cluster. अब जो आप टेबल क्रिएट कर रहे हो वो टेबल क्लस्टर में कैसे क्रिएट होगी? So syntax will remain the same. I think we have learned the 2 types of syntaxes. 1, create table and we provide a structure. Second, we have used create table name, and then we use a keyword as. So with both the keywords, we can create a table in the cluster. So you can see it's very simple and easy to understand. We can say create table Bollywood T1, because I'm creating a one table called as a Bollywood T1. Now this T1 I want to be a part of a test cluster. So simply before the as keyword, we'll use cluster name, and cluster column. Cluster column is nothing but a cluster key. So create table name, cluster name, ID. ID is nothing but a cluster key. Correct? As select star from existing table where gender equal to F. So this table will be a part of this. Same way you can create another table. But when you are creating a fresh new table, create table employees and we provide a structure. Structure is nothing but a columns. So in that case, you have to simply use the same syntax, but after closing the bracket. Here, before the as. Here, after closing the bracket. So you have to say cluster name, cluster key. So remember one thing again. First step, create a cluster. Step number 2, create an index on the cluster. Step number 3, create a table into the cluster. Very simple here. Now sometime question is asked, can we move our existing table into the cluster? So answer is no, we cannot. Because here, simply that table is already created, which cannot be a part of the cluster. Simple. So I hope this cluster part is clear to everyone. Now finally, we can drop the index or we can rename the index. So this cluster is also part of the index, because many times the question is asked, what's the difference between the simple index and cluster index? So the syntax for dropping an index is drop index name. Practically also we have seen that I have dropped one existing index. Same way, simple. If anything has to be dropped, you have to be used a keyword drop. Drop index name. The syntax for renaming an index, also the same. Alter index, index name, rename to new index name. So what is the meaning of rename? Changing the name of the index. Simple here. So finally, we understood everything about the indexes, whether normal index or a cluster index. Now we'll talk about a major part of this called as normalization. I'm sure everybody has heard the word normalization. What the normalization is? Normalization is nothing but a process to take a structure in a normal forms. Now we have seen that with the help of ER model also, we got a database structure. Same, normalization is also for the database structure. But the difference between the both is in ER model, we look at entity first, then their attributes. So it's a top to bottom approach. In normalization, we look at attribute first, and then we decide in which entity that attribute will go. So it's a bottom to top approach. So simply, what is a normalization? Database normalization is a process of organizing the field and table of the relational database to minimize redundancy and anomalies. Simple. Simply, normalization की जरूरत क्यों पड़ती है? Just to remove the redundancy and to avoid the anomalies. Simple. What the redundancy is? When we are storing a same kind of data multiple times, called as redundancy. Duplication is called a redundancy. That's it. Now let's say in a table called as billing, if I'm having a customer name and the product and the price. So in that case, if the same customer come for multiple time, we have to keep on storing his information multiple times. So that is a redundancy. Anomalies. So when we talk about anomalies, anomalies are of three types. One is called the insertion anomaly. When we are inserting a record, value of that is depends on some others columns value, and we are not able to insert. Now, for an example, let's say in a table, we have a PAN card number and rest other detail of the person. Name, address, all the things plus PAN card number, and PAN card number is a primary key. Now, hence primary key is there as a PAN card. That column will not accept a null value, plus that column will not accept a duplicate value. Now, for example, one person came to us and he says that you take all my detail, PAN card number I'll provide you tomorrow. Can we insert his record in the table without PAN card number? Answer is no. That means all other details are depending on one column value. And that column value is not available, so you cannot insert entire row. That is called the insertion anomaly. Clear? Second is called the updation anomaly. What is the updation anomaly? When we need to update one small thing, but उस अपडेट करने के लिए हमें अगर एक से ज्यादा रोज अपडेट करने पड़े, then it is called as updation anomaly. Very simple. Clear here? Third is called deletion anomaly. What's a deletion anomaly? When you are deleting one fact, then other fact also get lost. That is called the deletion anomaly. अगर हमको कुछ एक छोटी सी चीज डिलीट करनी है बट उसकी वजह से अगर पूरी रो डिलीट करनी पड़े, obviously in a delete you cannot delete a part, you have to delete an entire row. So when you are deleting one fact, other fact of the data is also get lost, is called a deletion anomaly. Simple here. So database normalization is nothing but a process to organize the columns and tables to minimize the redundancy and anomalies. So simple. Now the word is minimized used because it is never possible to reduce entire thing. Then the other problems can occur. Normalization usually involve dividing a large table into a smaller and less redundant. Very simple here. Not only we have to break the table, but we have to maintain the relationship between them. That's called a normalization in simple words. Unnormalized data exists in a flat file. What is a flat files? Simply a flat file is nothing but whenever you have data with a comma separator, or you can say when you have an unrelated data at the same place, called as a flat files. And normalization is a process of moving the data into related table. This is usually done by running an action query. What is an action query? When your query affecting the actual data is considered as action query. I hope everybody remember that we have done, we have used a create table statement with as keyword. What does that as keyword does? It copy the data as well. So that will be called as action query. Simple here. Now anomalies. We have already discussed. This is just for your understanding once again. First is a deletion anomaly. Deleting one fact or data point from a relation will result in another information being lost. Insertion anomaly. Inserting a new fact or a tuple into a relation requires we have information from more than one entity. This situation may not be feasible. We have taken an example of the PAN card. Simple, that is a insertion anomaly. Updation anomaly. Updating one fact, small thing, in a relation require us to update multiple tuples. So that is anomalies. And what does a normalization does? It minimizes the anomalies and it minimizes the redundancy. Now, we know that normalization is nothing but breaking a large table into a small number of tables. Now, when you are breaking the table, that time, can we break the table from anywhere? Let's take a simple example. Okay, I'll remove all this first. Okay, let's say we have a table in which we have a invoice number, date, customer name, then I have his address, then we have his contact, then we have a product, then we have a quantity, then we have a price. Okay, so now let's say this is the table. And let's say invoice number is a primary key. Okay, now for inserting anything, invoice will require. अब कोई कस्टमर अगर इंक्वायरी करता है लेकिन परचेस नहीं करता है, he is going to purchase tomorrow, but he provide all his information, that is name, address, कॉन्टैक्ट, क्या परचेज करने वाला है, कितना, everything he provides you, but you cannot insert in this because अब तक सेल कंफर्म नहीं हुआ है. You cannot generate the invoice, so this will be called a insertion anomaly. Correct? Now let's say somebody has purchased something. Somebody has purchased something. Second day he returns it. After returning his product, what we have to do? We have to simply remove his record from this. If I'm removing, entire row will get removed. Correct? So when entire row is getting removed, his name, address, contact, everything is lost. हमको सिर्फ सेल कैंसिल करनी थी, उसकी डिटेल चाहिए थी फ्यूचर मार्केटिंग के लिए. But what happens here? That is also lost. That is a deletion anomaly. Correct? Updation anomaly. Now let's say Mr. A has visited our shop multiple times. अब उसका एड्रेस मुझे चेंज करना है, तो कितने रोज में करना पड़ेगा? ऑल दीज रोज. एक एड्रेस चेंज करना है, लेकिन कितने बार करना पड़ेगा? दैट इज अप टिल हियर. Simple. So all this is called the updation anomaly. So okay, so this was a anomalies. Now apart from this anomalies, what is the normalization? Breaking this large table into a small number of table to reduce the redundancy and anomalies. अब मैं इसको कहीं से भी काट सकता हूं. Can I cut it from here and take a separate? This is another table, this is another table. Is it can be done? No, because ये एड्रेस का कोई मीनिंग ही नहीं है इस टेबल में, क्योंकि एड्रेस किसका है. So this also should go here. Correct? So what is the simple meaning? When we are cutting, we always check कौन से कॉलम साथ में जाएंगे. करेक्ट? और कौन से कॉलम साथ में जाएंगे ये चेक करने के लिए we always look at functional dependencies. We always look at a functional dependencies. So what is a functional dependency? It's a constraint between the two set of attributes. Very simple. Now in functional dependency, we have two things. One is called a determine dependent, and one is called as a determine. Simple. So simply we can say an attribute or a set of attribute X is set to functionally determine another attribute Y, always written in this way. X determine Y means what? Y की value X पे depend करती है, या फिर Y की value को X ने determine किया है. That's called a functional dependency. So simply we can say that अगर X की value हमको दी है तो हम Y की value determine कर सकते हैं. That is a functional dependency. Okay, so in this lecture we'll stop here. We'll continue in the next lecture with functional dependency and complete normalization.